An AI agent can plan and still retrieve the wrong data. If you use AI for research, this episode gives you a screenshot-ready board for separating generative planning, deterministic retrieval, and human acceptance, so you can decide which work belongs to each layer. In June 2026, Anthropic published an evaluation of biology agents that tested whether they could retrieve viral sequence data from public databases. The result exposes a practical boundary. An agent can produce a convincing search plan and still return very different answers to the same exact data question. The results became much more stable when deterministic tooling handled the underlying retrieval. This video is packed with practical, high-value insights to help you get better at using AI. It's a longer one, so follow Tiny Agent and save it so you don't lose it. First, identify the work that belongs in AI planning, so you keep its most valuable exploratory ability without handing over the entire evidence chain. AI is useful for turning a fuzzy goal into sub-questions, naming the entities to find, proposing a time window, listing filters, and suggesting possible data sources. It can also generate several search routes, start with a review, locate the relevant database, then add missing keywords, aliases, and domain-specific terminology. When a page changes, an entry point fails, or the available context is incomplete, the agent can explain the blockage, reorder the plan, and ask for the next piece of information. Those actions create useful candidates. They do not guarantee that every underlying record or count will be identical on the next run. That is why asking AI for a plan, assumptions, and unresolved questions is safer than accepting an untraceable final number as the deliverable. The human's first job is to define the actual decision, the allowed source boundary, the output schema, and the actions the system must not take. Chapter Recap. First, AI is well suited to decomposing a question and generating search routes. Second, the plan should expose assumptions, candidate sources, and unresolved gaps. Third, a human defines the goal, source boundary, and acceptance format before retrieval begins. Next, identify the data that needs deterministic retrieval, so you know when the model should stop browsing and guessing. Database identifiers, exact counts, fixed filters, version numbers, and access dates are better returned by an API, command line tool, or structured query. Deterministic does not mean the world never changes. It means the same input, parameters, and data version produce a reproducible result with a complete log. These tools encode batching, pagination, field parsing, and local filtering as fixed steps, reducing the chance that an agent misses records while navigating a web interface. When a result enters a report, research conclusion, customer deliverable, or downstream automation, both the exact retrieval and the query trace must be runnable again. AI can still explain the structured result, compare differences, and draft a summary, but it must not silently rewrite a critical number returned by the tool. A human chooses the trusted tool, locks the version and parameters, and decides which fields must be checked against the original records. Chapter Recap. First, use deterministic tools for identifiers, counts, and fixed filters. Second, preserve versions, parameters, and logs so the same input can be reproduced. Third, let AI explain the result while a human owns tool choice and critical field acceptance. Now examine the source evidence, so you can see why a polished plan does not replace deterministic retrieval. The researchers built VirBench with 120 realistic queries across 40 human viral pathogens, plus expert-verified ground truth counts. Mean accuracy across the tested agents ranged from 16.9% to 91.3%, so a single successful demo could badly overstate reliability. For one identical Ebola query, the same Sonnet 4 agent returned 106, then 15, then 5, while the verified answer was 266. The problem is not only whether the model can reason. It must also navigate pages and interfaces, paginate, filter, interpret unstructured output, and recover from errors. Any one of those steps can drop records. The final response can sound fluent and include a plausible explanation, but only known ground truth and repeatable execution reveal whether the data is complete. This evidence applies to viral sequence retrieval. It does not imply that every task has the same error rate, and it does not mean AI is useless for research planning. Chapter Recap. First, 120 queries exposed large differences in retrieval reliability. Second, the same query can produce sharply different counts, and fluent language cannot substitute for ground truth. Third, the numbers belong to this retrieval case and should not be generalized to every agent task. Next, combine the two kinds of work, so you get a workflow that preserves exploration while keeping critical data auditable. Step 1 belongs to the human. Define the decision, allowed sources, required fields, and the cost of getting the answer wrong. Step 2 belongs to AI planning. List entities and aliases, propose a query order, write filters, expose assumptions, and identify missing context. Step 3 sends exact retrieval to a deterministic tool. In the source, gget coordinates official interfaces, batches requests, applies local filters, and returns standardized data with logs. With that tool, every tested agent exceeded 90% accuracy, GPT-5. 5 peaked at 99.7%, and run-to-run variability was largely eliminated. Step 4 returns to AI for interpretation, compare structured results, flag anomalies, and create a human-readable summary while preserving links to the original fields. The human then samples critical records, checks the evidence boundary and risk, and decides whether to accept the conclusion or expand automation. Chapter Recap. First, a human defines the decision and the cost of error. Second, AI plans and explains while deterministic tooling retrieves critical data. Third, a human verifies key records and keeps final acceptance authority. Finally, compress the workflow into one handoff board that you can reuse for research, competitive analysis, and data reporting. Column 1 is goal and context, the real decision, allowed sources, time window, required output fields, and forbidden actions. Column 2 is AI planning, sub-questions, entities and aliases, query order, assumptions, gaps, and the questions that require more context. Column 3 is deterministic retrieval, the fixed tool, version, parameters, original records, exact counts, error responses, and execution log. Column 4 is AI interpretation, compare and summarize only from the tool output, flag anomalies, and never modify critical numbers. Column 5 is human acceptance, sample original records, confirm the evidence boundary, judge risk, and sign off on the final conclusion. Take over immediately when no trusted deterministic tool exists, repeated results conflict, sources cannot be traced, or the conclusion affects health, money, public publishing, or another high-consequence action. Screenshot this handoff board and use it in your next research workflow. Chapter Recap. First, AI owns planning and interpretation, not every retrieval step. Second, fixed tools return critical data and preserve reproducible evidence. Third, a human accepts or takes over when evidence conflicts or consequences are high. To sum up, an AI agent can plan and still retrieve the wrong data. The reliable division is simple. Let AI generate the route and explain the result, let deterministic tools return identifiers, counts, and logs, then let a human accept the critical conclusion. This keeps the agent's exploratory strength without mistaking a plausible answer for a reproducible data fact. Which AI research task would you split into planning, retrieval, and acceptance first? Tell me in the comments. Follow Tiny Agent. Tiny Agent helps you get better at using AI.